All right, electromagnetism. That was our next unit where we talked about, we're still talking about current and moving electrons, but we combined that with magnetism, and we talked about how we would build an electromagnet, okay, or how we would create current in a coil using a moving magnet. And then we talked about applications of those, which were motors and generators. So this is like a word bank. We're going to use this list of words to fill in these different informations down here. This unit, we didn't have any equations, so we're just going to go through some kind of concept type stuff here. Okay. So 3 ways to increase the strength of an electromagnet. So remember we made an electromagnet in class. We used a nail, and then we surrounded it with a coil of wire, and then we used a battery we connected to. Okay. Oops, that's not a very good minus. I don't know what to do with that. Okay. Um, and then, like, the more coils we had, the more staples it picked up. If you remember, kind of how when we did that lab. So this was our current source because that provided voltage. These were our coils, and then the nail was our core. Okay. So 3 ways you can get a stronger electromagnet. Okay. A larger magnetic core. So I'll just cross off these words as I use them. Larger number of coils. The more coils we had, the more staples we were able to pick up. And increased current. If you've got a bigger voltage source, you can make some more current. You can have a stronger electromagnet as well. So core, coils, and current. Okay. So we talked about that kind of basic design, I guess, of an electromagnet. We also talked about magnetic induction. This was the simulation where we looked at we had a bulb. Oh no, my pen is dying. Really? Come on. Pain. Okay, so we had this simulation where we had this bulb, and he was attached to a coil of wire, and then we moved a magnet through the coil. That's not a very good drawing, but we moved it through the coil, and the light bulb came on. Okay, and that's called magnetic induction, where we're inducing a current by moving the magnet. Okay, so really what we're doing there is changing the magnetic field. And that's the key, is that your magnetic field's got to be changing. Remember, if we didn't move the magnet, the bulb didn't come on, right? So ways we could increase this type of electromagnet: we can move the magnet faster. So when we do that, we're changing the magnetic field more. We could also have a larger number of coils here. Remember, with this simulation, there was a second option where you could add another coil, and that made the bulb brighter if you had a larger number of coils. So I gotta cross off words up here. So. All right, and then we talked about examples of where electromagnets are used. Okay, they're used in motors. Okay, we'll start with motors. What does a motor use? A motor uses an electrical input to create a mechanical output. Okay, so an example whoops, of a motor would be a fan. Okay, like a small fan, because you plug your fan in, that's your electrical input, and then the blades spin, right? So you end up with mechanical output. This is a badly drawn fan, okay? But you plug it in, that's your electrical input, and then you get a mechanical output. There's lots of things that are motors. Many things throughout our households or throughout our school use the principle of motors, okay? Then generators are the opposite. A generator uses a mechanical input to create an electrical output. And generators are how like big power plants, okay, work. Um, so power plants are an example of a generator. A windmill, so like a windmill. That's really bad drawing. With a windmill, okay, the blades turn and they generate electrical power. Okay, so that's an example of a mechanical input where you've got a blades turning and that creates an electrical output. Okay, so that's all we have to say about electromagnetism. Not too much there.